Alright, today we're starting calculus, which is quite exciting. We're going to start with the idea of gradient again. So on a straight line, you would have seen, I hope, that the gradient is a measure of how steep the line is. So if you pretend you take a little roller coaster, that is a roller coaster, and you run it from left to right along that line, you'd be thinking about how steep that journey is. Right? But not just how steep, also we want to have some sense of whether it's traveling uphill or downhill. So say we put the roller coaster on this one and we let it run from left to right, it's going downhill this time, right? And the way we measured the gradient was by comparing how far up it's traveled, or down if it's negative then, with how far across it's traveled. Right. So the one on the left, because it's a very shallow climb, but it's going uphill, it would be a small positive gradient. Whereas the one on the right, because it's very steep and it's traveling downhill, it'd be a big negative gradient. Right. And the way you calculate that precisely would be to divide the yellow length by the blue length, the rise over the run. Now, we never tried this on a curve because things get a bit strange when you put the roller coaster onto a curve, which we're going to do. All right, so I'm going to put this roller coaster here, let it run from left to right, and I want you to think about what's going on there. So let it go. And I hope you can see the gradient isn't something you can just calculate as a fixed number. It's always changing, right? So it starts off being very, very, very downhill, right? But then it's going to go less downhill, so a bit shallower there, right? It goes flat at some point, but then it goes uphill again. And as it travels, it seems to get more and more and more uphill. Right? So we're going to run a few of them and make them stop at different times and try and describe what's happening when that happens. So the first one, the one on the far left, that is really, really, really steeply going downhill. So the gradient there, we should think is a big negative number, because it's so steep and it's downhill. Whereas the second one is still going downhill, but it's really, really shallow at that point. So you would think that the gradient there is a small negative number at that point. All right. At the middle one, it's right in the middle of that parabola, right at the bottom of the roller coaster. It's kind of flat there, isn't it? You can see where the arrow is pointing, it's flat there. And so the gradient there, it would be 0. All right. And then the next one, it's starting to climb uphill again, but it's really shallow there, so you would think the gradient's a small positive number, right? And the last one, because it's so steep and going uphill, the gradient would be a big positive number. And I think things can make sense if we just talk about them very informally like this, about what's happening to the gradient in words. But if you think about it more carefully, all right, we'd have to ask, what do we mean when we say the gradient at a point? What does that even make sense? I don't think it sort of makes sense that obviously, because if you have a point, you can't talk about gradient. It's got to move somewhere. It's got to have some sense of moving across and moving up and comparing them. And unless you have those measures, you can't think about the gradient. You can't just grab one single point and look at its gradient. Doesn't make sense to. Right? And we're not going to solve that today, right? That'll be next time. But if that is something that weeds you out, well, it probably should, right? And that's what the founders of calculus had to struggle a lot with before they came up with things that we know now today. But that is a problem, and I want you to sort of think about that, but we're going to let that sit until next time, all right? But for now, what do we know for sure? We know that the gradient of a curve changes all the time. Well, maybe not all the time, but most of the time it would seem to be changing. And it changes depending on where you are. And so the gradient itself must now be thought of as a function of x as well, not just a constant number. So when we dealt with straight lines, we'd have a gradient of 2, a gradient of 3, a gradient of 0 maybe for a horizontal line, right? But now we got to expect that the gradient itself, right, will involve x because it's going to change as you move along the curve. Okay? And we're going to spend the rest of today just trying to graph a gradient function. So we're going to give you a graph of a parabola here. and we draw that in yellow, and I'm going to try and build the gradient function in red, right? And what you want to be looking out for when you're drawing the gradient function is not how high or how low the graph is. That has to be irrelevant. And I think turning that off is sometimes the hardest part, that you need to ignore what the y-value is. You have to ignore how high or how low the graph is. All you care about is the slope of the graph, which means whether the roller coaster is going uphill or downhill and how steep it is. That's what you got to care about. So I want you to focus almost only on the direction that little arrow is pointing. That little arrow on the roller coaster that I've drawn there, right? That's the most important thing to be tracking today, right? And I think when we draw a gradient function, the easiest way is to give ourselves a few checkpoints, a few easy points to sort of act as markers, right? And often the easiest ones to start with are the ones where the roller coaster is horizontal, is flat, right? Any point where it turns is going to be a point where the roller coaster is flat. And so there, the gradient must be 0. So if I'm drawing the gradient graph, I know that at that x value, the gradient value must be 0. And so I've got that point there. Okay. Back to the start now. Over there. Well, over here, you look at the arrow, it's going really, really, really downhill, and so the gradient there should correspond to a big negative number. So at this x value, there is a gradient value of a big negative number. If we move a bit closer to the middle, to there, well, the roller coaster, I hope you can see, is still going downhill, but it's shallower. And so it's still a negative number, but the gradient is now a smaller negative number. By smaller, I mean in size, in absolute value, not in like actual number smaller. It would be a smaller negative number in that sense. Okay. And then it's going to go past the tip where the gradient is 0. And then as the x values go positive, well, the roller coaster starts to go uphill, and so the gradient goes positive here. And so at this x value, we have a positive gradient value. It's not very big yet because it's quite shallow here, right? But as you move further and further along the parabola, it would seem like, look at the arrow, the roller coaster gets steeper. And so this x value would correspond to a big positive gradient value. And so your gradient function would look a little bit like this. All right, now how do you know it's a straight line? Well, we don't know yet, and if you drew a vaguely uphill traveling squiggle, that'd be almost as accurate as you could be right now. That'd be fine, right? So we're not looking for precision today. We're looking for just the idea of gradient, a changing gradient, and being able to track it as you move along the graph. Okay, but a few takeaways. First one, points where the roller coaster goes horizontal must have a gradient of 0. Right. Then on the left, the points where the roller coaster is going downhill, well, they correspond to a negative gradient. And so the red function is a negative value. And points where the roller coaster is going uphill, well, they have a positive gradient. And so the red function is above the x-axis there. All right, we'll try the same thing for a more complicated function, and we'll stop there for today. So once again, I've drawn a curve with a y value in yellow, and we're going to try and draw the gradient function in red again. So what I find is the easiest again, first things to look out for are the points where the roller coaster goes flat. So it's going to be at the top of the hill. That's a flat point there, so its gradient value must be 0. There's another flat point there, so at that x value, the gradient value must be 0. And there's one more there. Okay, so pretty much whenever you're at the top of the hill or the bottom of the hill, your gradient value must be 0. So there's another one there. Okay, and so no matter how your gradient curve twists and turns, it's going to have to go through those 3 x-intercepts. All right, start on the left again. On the left, you see the roller coaster is very, very, very steeply going uphill. And so its gradient value must be a very, very big positive number. So that would correspond to a point somewhere up in the sky like that, okay? Because it's going so steeply uphill, all right? But as you travel a bit further towards that top of the hill, that gradient is going to shallow out very quickly, right, as you travel to the top of the hill. And so it's going to suddenly shallow out towards zero, which means it's going to decrease towards zero very quickly like that. Okay. And then once you go past the hill, the roller coaster is going to start traveling downhill. Look at the arrow again. It's going to start traveling downhill, which means the gradient at this x value, the gradient value goes negative. And then as you move further along, you get to about here, the gradient is still negative because you're still going downhill, but you can see it's much steeper here, right? Compare where it was before, close to the top of the hill. It's now gone a lot steeper. So that means that here, you're going to get an even more negative gradient there. But then as it reaches the bottom of the hill, it's going to have to shallow out again, which means the gradient will have to move back up and curve back up towards zero, where this flat point here is. And so the graph will do something like this. Then move a bit further along. Well, here, the roller coaster's back to going uphill, and so the gradient at this x value must be positive. Then as you move along, it seems to go even steeper uphill, and so it's going to get even more positive. But then once again, as it reaches the top of the hill, it's going to shallow out. And so that means that the gradient is going to have to curve back towards zero here. We're almost there. At this point, the roller coaster starts going downhill again, and so the gradient must go negative. And as it moves, I think it just gets more and more downhill, and we are going really, 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 really steeply downhill here, and so the graph just goes on forever like that. Okay, now that's probably going to be a bit confusing at first, but maybe watch that again and try and get your head around this link between the y value, the yellow curve, and the gradient of the graph, which is the red curve. But picture that roller coaster traveling from left to right, whether it's going uphill or downhill and how steep it is, right? And that should give you an idea of what that red gradient curve looks like. Okay, that's all for today. Thanks for watching, and I'll see you next time.